Today, computers are very easy to use. They display everything with intuitive colors, icons, and layouts. But under the hood, what is really happening? What's happening when you move your mouse, when you open a browser, when you change your background, or move some files around? Well, of course, your interactions are causing some code to run, and that code then updates the display. And that code is really just a bunch of files. Some of those files run when your computer turns on. They might do something like display your applications along the bottom of the screen or display the login screen. And some of them run when you take particular actions like move the mouse or rename files. And that's how everything in the computer works. You interact with something using the visual display, some code runs, and it does something which updates the display. We call that visual display the graphical user interface, or GUI, sometimes pronounced GUI. And the graphical user interface is just a layer on top of the code which is running that makes things look pretty. We don't have to interact with the computer through the pretty GUI though. We can also run the code directly. And we can do that using the command line interface, or the CLI. The command line interface is a way to talk directly to the computer without having to use the graphical user interface to then run that code. So why would you want to do that? Well, a few reasons. Graphical user interfaces are much more prone to human error compared to exact lines of text, which is the code that you can write in those command lines. And in systems that need to run automatically, there isn't even going to be a human to interact with the graphical user interface. That's another reason. And some popular applications widely used in industry, like Git or Airflow, don't have native graphical user interfaces. And in the case of other software, like Docker or MLflow, the graphical user interface just doesn't give you access to the complete functionality of that tool. We call it the command line interface because it provides a line where you can write text and send commands to the machine. And it's also known as the terminal or the shell. And in this video, we're going to get familiar with the basic terminal commands. Before we get started, if you're on Windows and you're serious about learning to develop software, stop now and install Ubuntu Linux. Windows is not an industry standard operating system for software development. It's going to cause you to face serious issues with installing certain software later on, and the Windows terminal will not work in the same way that I'm about to explain right now either. So if you've done that, or you're on a different operating system like Ubuntu Linux or Mac, then let's jump into it. So first of all, we need to open the terminal. All you've got to do that is search terminal and it should come up. Once we're in our terminal, we can see our command prompt. This is where we will write commands that the machine's going to run. And these commands are just code. Although they're all very similar, different terminals understand different commands. And that's because they run different programming languages. The most common shell is Bash, and ZSH is another very common one. You can often tell which terminal you're using by the name it gives the terminal. So you can see up here I'm using a ZSH shell. Very similar to Bash. I'll explain the differences as we come across them, but they're working exactly the same way. One of the first things that's important to understand about the terminal is that it's open in a particular location in your files. If you're not in the same folder, for example, you won't see files that you're looking for. You can see where you are by running the pwd command, which is short for print working directory. So this is my current location, and I just ran pwd for print working directory. Print working directory means print the folder that I'm currently in. Directory is just another word for folder. And when I say run a command, what I mean is simply type it and then hit enter. So you can see that I'm currently in this directory. So we can list the items that we've got in a directory using the ls command, which is short for list. And you can see the folders and files that I've got inside this location. Commands like ls can also take in parameters which we call arguments. For example, I know that the first argument to the ls command can be a folder that we want to list the contents of. So if I want to list what's inside this folder, I can simply type this. And you can see in this case, there's actually nothing inside it. But if there was some stuff inside it, it would show up just like things have above here. All commands take this form where spaces separate the commands and the parameters. And this is why folder and file names shouldn't include spaces, because if I wanted to list a folder name which had a space in and it looks something like this, then Bash is going to treat these as 3 separate parts of the command. It's going to think this is the first parameter and this is the second to the ls command. So avoid using spaces in file names or directory names. If you do find files or folders which have spaces in the names, then you can write the location within quotes, which would look something like that. And you can use single or double quotes there. You can also add what are called flags to the commands you're using. A flag is an option that you can set to a command. For example, you can tell the command to show you all the items, including hidden files, when you list the contents. Hidden files or directories are those whose names start with a dot. They won't show up in the graphical file explorer. To do so, you have to use the -a flag. Please, for consistency, don't call this dash a minus or a hyphen. Call it a dash. And you'll also save yourself those syllables. Now the output includes all of the hidden files and folders. Dot represents the directory itself, which you're listing the contents of. And dot dot represents the directory that contains the directory you're listing the contents of, one level above it in the file system, which is known as its parent directory. So dot dot is the folder which contains this one. The L flag for the ls command will show the contents in long format, displaying more specific information such as the permissions, size, and last modified date. These single character flags that I've just showed, like the -a and the -l, are known as short flags. They're often just the first letter of a corresponding long flag name. The corresponding long form flag name for the listing all flag might be --all. The key difference here is the use of 2 dashes instead of 1. In reality though, the ls command doesn't actually have any long flags, but many commands do, so that's just to illustrate the point. If it's 2 dashes, then Bash is going to try and interpret that as a long form flag. So when I run this, it tells me that it's an illegal option, and that's essentially an error. Doesn't matter, totally fine to get errors, just run it and see if it works. And you can often combine short flags by putting their characters directly together. For example, ls-al, which will get you all of the items in long format. Pay attention to the difference between the combined short flags. Long flags, which have a double dash, tell the machine to read the characters together as one word, rather than individually as different short flags. So when I run this, I'm actually saying use 2 short flags at the same time, the A flag and the L flag. And of course, you can also combine flags and arguments. So I could check all of the elements in a particular folder by doing ls-a and then the name of that folder. And this returns a list of all the items with their content permissions, owner, size, and item and the last modified date inside that particular folder. And with these examples, you can start to see a pattern on how to use commands in the terminal. The command you use can have flags and arguments, and the syntax would be something like this. Command, short flag, -- long flag, and then argument. In fact, argument 1, and then argument 2, and so on. Each of those arguments separated by spaces there. And every command in the terminal has that same format. Another terminal command, which I'm just going to use to tidy things up, is clear. It just clears the terminal. You can check the flags and arguments of a command in its manual by using the man command, followed by the name of the command that you want to get help with. So this is the manual for the ls command. It says up here the name of the command, what it does, it shows you how you can use it. So it says this is the name of the command, square brackets indicate that these are all of the optional flags, and then these are the arguments, and again, square brackets say that they're optional. You don't have to give a file name or a folder name of what you want to list the contents of. Then it gives a description, and scrolling down, it gives you the details of all of the different flags and what they do. And you can press Q to exit this manual. Not all commands have a man page, and if they don't, you can try and run them with the -- help flag, which usually shows the manual. And if they don't, you can try and run them with the -- help flag, which usually just shows the manual. Here are some other quick things that you should be aware of. Some commands can take multiple arguments, which come one after another, separated by spaces. For example, specifying what file to move and where to move it. You might do something like this, where the from and the to are two different locations on your computer. Another thing to be aware of is that some flags are not just on or off, like the -L flag, which is either long format on or long format off. Some of them actually take arguments. So in this case, you would just leave a space after the flag and then specify the argument to put in that flag. Or you can put an equal sign directly after the flag. If you can't understand the manual, or you just don't know the name of a command, you should just look it up. I am constantly looking them up, and you should be too. So let me show you how to do that. So I'm going to go to Stack Overflow, pretty reputable source, take a quick scan of the question, okay, cool, looks good, and then down here is the answer. So I just say CD, and then the name of the location which I want to move to on my computer. And if it wasn't clear already, what this is saying there's a project folder inside a C folder. So if I want to change directory, I can do CD to another directory like that. And then you'll see that my prompt changes because my prompt includes where I am currently. And I can prove that I've moved there by running pwd to print my current working directory, and you'll see that I am in fact in another directory. But why does the output of pwd look so long? I didn't have to write all of that to move into this folder. We just use what's called a relative path to indicate the location of the folder we wanted to move into relative to our current directory. On the other hand, pwd returns you what's called an absolute path. That's the location relative to the very top of your file system. The absolute path shows every folder separated by a /. So this folder is within this folder, which is within this folder, which is within this folder, all the way up to the top. Relative paths can also include folders nested within each other, separated by slashes, but they don't show every folder all the way up to the file system. And the very top of your file system is called the root. It contains all of the memory on your computer, and it's represented by a single / as its file path. So if I run cd /, then I'm going to go into the root file system of my computer. And if I ls there, you'll see all of these folders which contain things like my operating system, and my user is somewhere in there. Here, you'll find a lot of stuff that you shouldn't touch, including the files that run the operating system and files that run applications you've installed. To get back to somewhere nice and safe, you can run cd with no arguments. This takes you to what's called your home directory. In here is just the stuff that's to do with your user profile. The home directory is the default place that your terminal will open up in. And similarly to how other key locations are represented by a symbol, like the root is represented by a /, the parent directory by a .. The home directory is represented by a tilde, which is the little wave. So cd tilde is the same as cd. The default argument to this cd is tilde, and that moves you to your home directory. And if you pwd, you can see the absolute path of that. It's key to remember that the parent directory is represented by a .. because without that, you can't move back up. So if I'm in my terminal demo and I cd into another directory, then how do I move back up? Well, I have to do cd ... That is change directory to the parent directory, and then I'll go back up. If I want to go up multiple directories, I can do cd ... /... however many times I want to go up. So this will take me up 3 levels in the tree structure of my file system. So here's 2 other important tricks for using the terminal. One of them I've been using throughout this video, which is that you can hit the tab button to fill in the rest of the path or command if there's only one possible option. So if I try and do cd an, and I hit tab, there's only one option, which is another directory. And so bash fills that in here. And another useful trick is that if you want to run a command again, just hit the up key to see your previous commands as many times as you need to go up. So if I press up, you'll see all the previous commands I've ran, and then I can go the other direction by pressing down, all the way down until I get to the most recent command, which I just typed. So take a second to remember that everything we've just done is possible using the graphical interface too. Looking at your current folder, showing folder contents, moving around folders, that's all possible in the graphical interface. And I know you know exactly how to do that stuff using the graphical user interface, and now you know how to do it using the command line interface too. So these are the basic commands to navigate through our directories and explore them.